Hey guys, so in this video we're going to be talking about, we're going to be going over IXL section K.1 underneath the Algebra 2 section. This topic is polynomial vocabulary, so we're going to be discussing some of the names and terms of things regarding polynomials. So our first question is to find the degree of this polynomial. So it's helpful to know what a degree is, and a degree is just the highest power within a polynomial. So as you see here, we have a polynomial, and we know this is a polynomial because it has many terms in it. And remember, that's all that a polynomial is. It's something with many terms in it. And so a degree is the highest term in a polynomial. And so how are we going to determine the highest term? Well, we're going to look at the powers of each of these terms. Okay? We can call those the degrees. Well, what is the highest degree of it? Well, that's just going to be 9 right there. So then we're going to end up calling this a polynomial of degree 9. And it's just that simple. We were looking for the highest power. Alright, so find the degree of this polynomial. So this is just a monomial because there's only one term in it, just the 2b to the power of 9. But regardless, we're still going to look for the highest power, which is 9. So our polynomial is of degree 9. Okay, we have a slightly different question now. It's asking for the number of terms in this polynomial. So the number of terms, like we were saying before, we're going to classify these as algebraic terms. And what defines an algebraic term is a unique variable raised to a unique power, meaning that f right here is a unique variable, but it also has a unique power on this. And I know you can't quite see it, but we can treat this like it has a power of 1. We can do that with any number. And so we can say that f to the power of 1 is a unique algebraic term, therefore that is one term right there. Likewise, we can repeat this counting process, and we see f to the power of 3, that is another algebraic term, unique variable with a unique power. Likewise, unique variable, unique power, f to the power of 5, and f to the power of 6. So now we go ahead, we just count these all up, and we have 1, 2, 3, 4 terms in this polynomial. Okay. Fun fact, I think we call that a quadric form polynomial. It sounds almost like quadratic, but it's not quadratic. I believe it's quatric. But either way, you can just say it's a degree 4 polynomial. Alright, so same deal. So find the number of terms in this polynomial. And so we're going to go ahead and count them. We have 1 term, we have 2 terms, 3 terms, and 4 terms. So we're going to have 4 terms in this polynomial. Okay. Alright, so same deal. We have to find the number of terms in this, and this is, of course, what we call a monomial because there's only 1 term in it. So there's only 1 term in here, which makes it a monomial. Okay, so now we also have to find the number of terms and the degree of it. So the number of terms, well, we have just 1 term. Whoops, keep on doing that. We have just 1 term in here. And the degree is going to be, well, we have a highest degree of 3, so our highest degree will be 3. Alright, so again, same deal. So we need to find the number of terms, and we need to find the degree of it. Remember, the degree will always be the highest power. So we're going to look for the terms. We have 1 term, we have 2 terms, so we have 2 terms in here. And now as far as our degree, we're going to look for the highest power. We have a power of 9 and a power of 8. So our highest power will be 9. Okay, so same deal. We're going to go ahead and count the terms. That's one term, that's two terms. So we have two terms in here. And our highest power is just going to be 2. Okay, now if anyone's curious, you may be asking, well, imagine what if I didn't have this one right here, and what if I had just this one? You would actually say that your highest power is actually 0, because you could treat this one as having n to the power of 0, because n to the power of 0 is just 1, which means that any number without a variable can be considered the 0th power of that variable. Okay, so same deal, right? Two terms right here. And we have a highest power of 1. And remember, that degree is going to be 1 because we see a term without a variable and a term with a variable. And so we can think of this one as having, I'm sorry, that's mistaken. We can think of this term right here as having a power of 1. And likewise, this 2, we can think of it as having a power of w to the power of 0. Right, we can think of it as being 2 times w to the power of 0. In this case, now we see that both of our powers are 1 and 0, and so our degree of it is going to be 1. Okay, alright, so find the number of terms. This is going to have just one term in it. And the degree of this is going to be a degree of 7. We only have one term in here, so our highest degree must be 7, because that is our only power. Okay, so now we also move on to some of the names of these. Again, not too hard, but it's important to know what these mean. You know, like you probably already know, monomial. Oh, I didn't realize I would select it. Okay, I guess we get another chance. So a monomial is just going to mean 1, right? This just means one term. A binomial is going to mean 2 terms, right? And you're probably thinking, you know, bicycle, lots of things that begin with the word bi, right? Bi just means 2. And tri is going to mean 3, so that is a 3-term polynomial. You can think of a triceratops, you can think of a tricycle, all those great things. And likewise, I didn't say it, but you know, a monomial, you can also think of carbon monoxide. That's a molecule that has only one oxide in it, or one oxygen in it. So the wording can be pretty intuitive, but that's just what it means. So we see that negative h is our polynomial, and there's only one term in that, which means it's a monomial. Okay, they're really kind of making this one easy. Notice again, we're looking for the number of terms, not the degree. This would be a degree 5, but as far as the number of terms, there is only one term in here. Right? Just one variable with a unique power, so that's going to mean there is only one term, or mon terms, or a monomial. So this would be a monomial. Okay, and so now there's another way to classify polynomials, and it's going to be regarding the degree of them, and there's more words we can use to talk about these degrees. So anything that is to a power of 2, we're going to call quadratic. So degree 2 is going to mean quadratic. Degree 3 is going to mean cubic, and degree 1 is going to mean linear. Again, we do have some other more unique words for higher degrees, but we're actually going to stop just at cubic. So now we just need to look at these options and figure out, well, what's the degree of our polynomial? we see that we have a highest degree of 2 right here, which means that we will have a quadratic on our hands. Okay. All right, so same deal. Now we're looking to again classify it in terms of its degree, because they're giving us options of linear, which just means degree 1. Cubic, which means degree 3. And quadratic, which means degree 2. Do not be fooled by quadratic. I know we see that word quad in there, and we might want to think that means 4. But quadratic is actually something of degree 2. Alright, so same deal, we're going to look at this. And we don't see the power on this, but remember this can be equal to 3x to the power of 1. So we see that our highest power is 1, aka this has a degree of 1, and maybe you can remember the word we're going to use for a polynomial of highest power of 1 is going to be linear. Okay, so just highest degree of 1, that's all it means. Just linking the words up with the numbers. Alright, so now they're kind of switching back and forth. So now they're asking us, what kind of nomial is this? And we look at this, and we see only one term. Remember, when we're talking about nomials, we're talking about algebraic terms. And I look at this, and I only see one algebraic term, which means it's going to be a monomial. Okay, so notice they give me cubic, linear, and quadratic. This is referring to the degree of it. So my question is going to be, what degrees are these? And hopefully by now you should start to know that linear means degree 1, quadratic means degree 2, and cubic means degree 3. So we're going to look at this. Remember, we don't see the power, but it could be a power of 1, which means this would be linear. Okay. All right. So again, we're looking for what kind of polynomial this is. I look at this and I see that there is a term right there and a term right there. So that means I'm going to have two terms, or I have a binomial on my hands. Ooh, the challenge zone. And I think, well, you know what? We'll go ahead and we'll work on this one too. All right, so find the number of terms and degrees of this polynomial. So, oh, this is a tough one. If I'm not mistaken, you always want to take the highest power of any variable. So, and I'm kind of guessing on this one. So first off, we can go ahead, count the number of terms. Nothing about that changes. We see that this has 5 terms. And now when we go ahead and talk about the degree, I believe we are now going to look for the highest power among the entire expression. So we look for the highest power among the entire expression, and I think it would be this one, my u to the power of 7. So let's go ahead and try out. Nope. Did not want that. There we go. A highest power of 7. So let's go ahead and check that and see if it's right. Oh, no, I got it. Oh, okay. So my apologies, I had a suspicion that might be it. So we're actually just going to count the degrees of all variables in here. Okay, this is terminology, it may not seem too important, but it's good to be able to speak the language. So notice that was the only mistake, right? The degree was 9, and we would have gotten 9 by using 7 and 2. So let's go ahead, let's do another one. Oh, it pops us back down. Okay, so we look at this expression right here, this polynomial, and it is, well, it's not a monomial, there's more than one term here. Right, we notice way more than one term. It's not a binomial, we notice more than 2 terms, and it's not trinomial because we notice more than 3 terms. So this is going to have to be none of the above. And we could actually just kind of call that a 5-term polynomial. I think the technical terminology would be like a quint polynomial or a quant polynomial. But again, we're not going to dabble with that. All right, so we're going to go ahead and classify this polynomial. We have only one term right here, which is going to make this a monomial. Okay, we have to find the degree of this polynomial. So now, remember, as we previously learned, we're going to go ahead and count all powers, not just of any one variable. So this would make this one a highest degree of 7. Okay, so this polynomial, we're looking for the degree or the number of terms. We see they give us quadratic, cubic, linear. That's referring to the degree of our polynomial. So we're going to ask, what's the degree of this? Well, I have j, which technically has a power of 1, and a power of 1 as a highest power is just linear. Okay, so same deal, we need to find the number of terms. So we're going to look at this, and, well, first, I guess, yeah, let's count the number of terms. So we have 4 terms here. So we have 4 terms. And now, for our degree, again, we're just going to look for the highest combination of powers. So when I look at this, I see that I have a degree of 2 right there. A degree of 1 and 1, which would make 2 for this one. Well, actually, we'll go ahead and write the degrees above it. D squared, that would have a degree of 2. And just D, that would have a degree of 1. So I actually have a lot of tied degrees here, or degrees that have the same number as each other. So my highest degree would actually just be 2. Oh. It would help if I answered everything. There we go. Okay. Cool. We'll go ahead, we can do a couple more. So classify the polynomial. Well, I see that it has a highest degree of 4. Degree 4, I believe that's a quintinomial or a quintic or something like that. But either way, you know, we're not worried about those. We only see linear, quadratic, and cubic. That's powers 1, 2, and 3. We have a degree 4. So none of the above. Okay. Again, so we look at this one, and it has a highest degree of 1. And there is only one term to it. So this is going to be a linear. And we could actually call this a linear monomial if we want to be completely correct about it. Alright, find the degree of this. So remember, we are going to combine the degrees. We're not just going to look for, you know, when it's a single term, we combine the degrees of it. So we have degree 4 and degree 5. That makes a total degree of 11. Oh, no, oh my gosh. Oh, what am I talking about? I can't do math. That's going to make a highest degree of 9. I don't know how to add 4 and 5. I'm sorry, guys. Okay, ooh, this one again. This was the tough one. So remember, right, when we're looking for the number of terms, not too hard. We're just looking for the algebraic terms that are being added together, right? Unique variables with unique powers. So this would be 1, 2, 3, 4. So there would be 4 terms in here. And then our degree, remember, we're going to look for the highest total degree of any of our terms. This one has a degree of 9. This one has a degree of also 9. This one has a degree of 1. And this actually has a degree of 0. There's no variables in it. So our highest degree is going to be 9. Cool. Okay, we'll go ahead, call the quits right here. I hope that was helpful. Yeah, leave comments below. Let me know what you think in class, and we'll see you later.